Chapter number 13, magnetic field due to current in a conductor. That is the topic number 3 of chapter number 13, subject science of standard 10. Now let us try to understand the magnetic field due to current through a straight conductor. Now what is straight conductor? For example, if this is a straight conductor and just as shown in the picture, just shown in the screen on your mobile or on your laptop, it is very clear that if the direction of the current is something like this and the downward, then the direction of magnetic lines of force, the direction of the magnetic field can be represented by the circling fingers like this. So this is the direction of magnetic field around a circular coil. We have already learned in the previous videos that the magnetism and electricity, they are just like Sita and Gita. Means they are interrelated each other. They are related to each other. Electricity and magnetism, they are just like twin sisters, judwat behne. And one is affected by other. One is produced by other. Electricity converts into magnetism and magnetism converts into electricity. Right? So, if this is the direction of current, then the direction of the magnetic field which will be produced due to this current will be given by this. So, the direction of the magnetic field will be like this and it will be circular in the nature. As shown in the figure, you can very clearly see that they are the rings, they are circular in shape. Magnetic field will be circular in a shape. And this is nothing but the right hand thumb rule. Now what is right hand thumb rule? According to right hand thumb rule, direction of the direction of circles of a magnetic field can be given by the direction of the field if we represent the direction of the current with the help of the thumb. So if this is the direction of thumb, then this will be the direction of magnetic lines of force. So this is known as right hand thumb rule. Next is the magnetic field due to current through a circular loop. Now suppose this is a long conductor and the direction of the current is like this. Then we have already seen that according to right hand thumb rule, the direction of the circular magnetic path, the direction of the magnetism which will be produced due to this electric current will be like this. But what will happen if we just bend this into a circular loop? So if we bend the long conductor in a circular loop, then it is very clear that if this is the direction of the current which is now bent to the bend of the conductor, then the direction of the lines of magnetic force will be something like this. According to right hand thumb rule, the direction of current, direction of magnetic field, direction of current, direction of magnetic field. So it is very clear that this will be the direction of magnetic field. If this is the direction of current, then inside the ring, this will be the direction of magnetic field. And at the periphery of the conductor, the direction of the magnetic field will be coming out, right? So it will be this thing. It will be like this. But here it will be like this. So it is very clear that if we bend a conductor, straight conductor in a circular shape, then the direction of the current, direction of the magnetic field due to circular loop will be something like this. It will be pointing towards or inside the paper, inside the screen. So this way we can represent it. Now let us try to understand or extend the concept in a circular coil. See, this is a circular coil, right? A very big circular coil. And if we try to understand the direction of the magnetic field which will be produced due to current with this circular coil, then we may say, according to right hand thumb rule, if this is the direction of electricity, then this will be the direction of magnetic field. So what do we observe? That the direction of the magnetic field is coming inside, coming towards me. It is coming inside. It is coming inside the coil. If this is the direction of current, then the direction of magnetic lines of force inside the coil is coming towards me, is coming inside, is coming towards me. But what about the outer periphery? it is coming out, right? If we consider that there are millions of the magnetic lines of force which are coming inside this circular loop, and if we assume that they are straight line, then it is very clear that if this is the direction of the current, then the circular loops, if they are straight, then they are coming like this. So this is the direction of current. So this is the direction of magnetic field. And we may say, in case of bar magnet, what we have observed? In case of the bar magnet, we have observed that always north emerges the magnetic lines of force. So magnetic lines of force always used to come from the north side. So we may say that this is the direction of the magnetic lines of force. So this is the north pole and this is the south pole. But in reality, we will have to simply give the direction of the magnetic field. This is the direction of current. Then this will be the direction of the magnetic lines of force. But if we change the direction, then direction of the magnetic lines of force will become like this. And one thing is very clear, that if we would like to swim, then we will have to try to understand that somebody says for swimming we'll have to do like this, then we'll have to take deep breath, then we'll have to go inside the water, then again come out, then we will be never able to learn swimming. For swimming, we will have to jump into the water. We will have to try our own. Same thing is applicable with this. You will have to learn. If you will have to learn the direction of this magnetism electricity, then you will have to try to understand the concept with your own mind. You will have to just visualize the concept for the direction, and then you will be able to understand. Now the last topic of direction, that is the magnetic field due to current in a solenoid. Now what is solenoid? Solenoid is nothing but a simple magnetic soft magnetic core, or say something like steel core or soft iron type core. It's generally used to be cylinder in nature. It is a very big. I have shown is something like, it is actually drawing sheet, but it is quite big in nature. Actually solenoid is something like this. For example, if this is the solenoid and if we just wrap the number of turns of a copper wire, then what do we observe? If we used to pass the current in this copper wire, see, this is the direction of the copper current wire, and this is the direction of the current in that copper wire. And if our fingers are pointing towards the direction of the current in those loops, again I am repeating, if this is the direction of turn of a copper wire wounded on this solenoid. What is solenoid? Solenoid is nothing but a cylindrical core on which copper wires are wrapped, copper turns are wrapped, and current will flow like this. If current will flow like this, means this, and if direction of the current in these turns is represented by our fingers like this, then the direction of the thumb will represent the direction of the magnetic field. So we may say, if the direction of the current in a solenoid is something like this, then the direction of the magnetic field which will be produced due to this current will be something like this, means north will be here. If this is the direction of electric current, then north will be here and south will be here. Again I am repeating, you will have to try to understand the concept, you will have to try to visualize the concept in your mind, then you will be able to understand. Now the next topic is that of the current carrying conductor solenoid is used to magnetize steel rod inside it, and that is known as electromagnet. So what is electromagnet? Electromagnet is nothing but, suppose a core of iron is there and we have wrapped few tons of a copper wire around it, and if we give current as shown in this figure, see, there is a nail or a piece of iron around which we have wrapped few tons of the copper wire, and now what we have done, we have simply switched on the power, we have simply switched on the battery, then current is passing through this iron, this nail. Then we have already seen in this last point that this solenoid will try to behave as a magnet. If this is the direction of current, then this will become north and this will become south. Means it has become now magnet, and it is known as electromagnet. So electromagnet is nothing but electromagnet is an artificial magnet which has been prepared by providing current to a solenoid, which has been prepared by passing current in a coil, and then this coil will behave like a magnet. And it is very clear as shown in the figure that when we switch on the supply, instantly the electromagnet will come into picture. This electricity will generate magnetism, and this magnetism will show the effect on a compass, on a magnetic needle, and it will start deflecting. Means with this experiment it is very clear that whenever we pass electric current in a solenoid in a few tons of a copper wire wrapped around any iron body, then it becomes magnet, and that magnet which we ourselves have produced artificially is known as electromagnet. And due to this magnetic effect of this electromagnet, magnetic needle will start deflecting. Now this is the application of that electromagnet. If we make very big electromagnet, there are many hundreds of the tons of say copper wire around one core, and what will happen if we just keep on if we just give the supply, then that will become a very heavy magnet, heavy electromagnet, and that electromagnet can be utilized to lift iron material and whatnot. See, this is the crane which is used to lift the scrap. Okay, so these are the different applications of electromagnets. Now the next topic is that of force on a current carrying conductor in a magnetic field. A very brilliant item if you try to understand in your mind. Suppose there is a magnet and we have freely suspended a rod, right? And now if we pass the current, see, if we have passed the current through this freely suspended rod in which current is passing, then we have learned with the virtue of Oersted and Michael Faraday that electricity and magnetism are interrelated to each other. So when we are passing current in a conductor which is freely suspended, then that conductor will now behave as a magnet. It is very clear according to Faraday and Oersted. When we pass the current, that suspended rod will behave as a magnet, and this magnet, when interact with the real magnet, if SS pole or NN pole are there, they will repel. If N and S pole comes into picture, then they will start attracting. In short, if we pass current through a conductor, freely suspended conductor, then it will experience a force due to magnetic field. The moral of the story is that wherever we use to keep a current carrying conductor in a magnetic field, then it will experience a force. This theory you will have to understand deep in a mind to understand the concept of generator and electrical motor. Repeating, whenever a freely suspended current carrying conductor is placed, right, then what is hanged, then what we observe that when we pass current through it, it will become magnet, and when we bring another magnet, this magnet, as we have studied, that it may become solenoid or something like that, right, a bar magnet. Then this magnet and this electromagnet will have certain relationship. If N or SS is there, there will be repulsion. If N and this becomes S, then there will be attraction, right? So magnetic and electrical effect will lead to a force on a current carrying conductor, and that force can be given, direction of that force can be given by Fleming's left hand rule. If thumb represents motion, B, this pointing finger represents the magnetic field, and C, central finger represents current, then we may say that if all of these are kept perpendicular to each other, all of these should be perpendicular to each other. See, if this central finger, there are 5 fingers in our hand. Central finger is treated as the current carrying finger. Central finger represents current, forefinger represents field, FF, forefinger represents field. Central finger CC, central finger represents current, forefinger field, then thumb, M in the thumb, thumb represents motion. Okay, so if the direction of current is given by central finger, direction of the field, that is magnetic field, is given by forefinger, then the direction of the force which will be exerted on that conductor which is carrying current in a magnetic field will be given by the Fleming's left hand rule. So by help of this rule, you can find out the direction of the current, direction of the force in which the conductor will try to rotate, the conductor will exert a force, the conductor will experience a force so that it will start moving. Now the next concept for extra marks, that is the magnetism in our body. Now these are the two items, heart and brain. I have already said that there are millions of the neurons in our brain which actually communicate with each other with the help of the electrical signals. And our heart, there is a SA valve which actually beats, this heart beats with the help of that SA node, and which actually operates with the help of electrical signals. And the person who are having defect in this SA node, actually that is known as pacemaker. They are given pulses from electrical device externally to make the heart understand that yes, these are the pulses on which I will have to beat, and it starts beating. So our heart beats, actually beats, वो नाचता है, किस पे नाचता है? इलेक्ट्रिकल सिग्नल. यहाँ पर नचाने वाला जो है वो इलेक्ट्रिक करंट है. किसको नचाता है? हार्ट को. So heart and brain, they are actually working based on electrical signals. Now what is MRI? MRI means magnetic resonance image. Actually with the help of MRI, we get the inside view, 3D view of our body. If there are any defect, we can find it out with the help of the magnetic lines of force which are actually inside our body and which interact with the external magnetic force which we are given through external forces, right? So with the help of interaction of these external and internal parameters, we conclude that what the actually 3D or 2D diagram of the object in our body is, and then doctor may conclude that is there any defect or not. This is Antarctic tern, a very famous bird, migratory bird, which comes from Arctic circle, and every year it comes to Middle America, right? Like USA and Cuba, etc., Canada, etc. It flies hundreds of kilometers, sometimes thousands kilometers. कितना अच्छा पंछी लग रहा है, ठीक है ना? ये हजारों किलोमीटर की दूरी करके तय करके अपने घोंसले पर पहुंचता है, वह प्रजनन करता है, बच्चे देता है, अंडे देता है, बच्चे देता है, और फिर बच्चों को बड़ा करके वापिस अपने अगर अंटार्कटिक में जब ठंडी कम हो जाती है तब चला जाता है. सो इतनी बड़ी दूरी वो एक्चुअली मैग्नेटिक लाइन्स ऑफ फोर्स जो अर्थ की होती है उसकी मदद से करता है. Next example from India. These are what? Flamingos, which we generally use to see almost throughout the India. Bharatpur, Rajasthan, a very famous bird sanctuary. Jamnagar, Khijadiya bird sanctuary. Right? Mumbai, there are many sanctuaries. Almost everywhere you will find these types of flamingos. राइट. एक्चुअली दे कम फ्रॉम द साइबेरिया. वहां पर जब ठंड बढ़ जाती है तो वो वहां से यहाँ आ जाता है. यहाँ जब गर्मी शुरू होती है तो वो वापिस अपने घर पे बच्चों को लेकर चले जाते हैं. हाउ डू दे गेट देयर एग्जैक्ट लोकेशंस ऑफ देयर ओन नेस्ट एंड एग्जैक्ट प्लेसेस? डॉक्टर सलीम अली, अ वेरी फेमस बर्ड वॉचर फ्रॉम आवर कंट्री, उन्होंने इसके बारे में काफी पता लगाया था. So actually magnetic lines of force of the earth, it's earth's magnetism, a very small magnetism, helps these birds come and go back to the original position. जहां से वो उड़े थे हजारों माइल दूर से, वहां पर ही वापस वही बढ़ जाता है। वो एक्चुअली अर्थ के मैग्नेटिज्म के कारण होता है, ठीक है। सो दिस आर द इफेक्ट्स ऑफ मैग्नेटिज्म on our body as well as these little tiny creatures. Stay tuned for more such videos. Thank you.